course on calculus for business. In this lecture, we are going to see about maxima and minima. So this name itself tells you that we are going to talk about some maximum value and minimum value. In general, we can call these values as optimum values. Okay. Here, let me give you the technical ideas and then we'll get into the problem. In this thing, we'll be given some function of x. So this function may represent a cost function or revenue function or a profit function or the what selling price. It may be anything, right? So if we are given some function and we are asked to find out its optimum value, that is, we may be asked to find out the maximum value or the minimum value. To find that, what are we going to do? So initially, to find this, step one is to find out the derivative. Okay, in the step we'll find the derivative and we'll equate this to, okay, let me write it in a more formal way. So find f prime of x, then equate f prime of x to 0 and obtain values of x. So when you equate your derivative to 0, that will fetch you some values of x. Obtain those values. Next, find the second derivative. Okay, step 2 is to find the second derivative. Okay, here you are going to obtain some values of x, right? So let us call them as x1, x2. We don't know how many values. Let us say n values in general, right? So when you obtain n values, now after finding the second derivative of the function, evaluate your second derivative at the points. Okay, if this is positive, then your xi is called minima. If your second derivative at this point is negative, then this value is called maxima, right? And finally, your function evaluated at this point. Okay, let me write this as xi and xj. Your f of xi is the minimum value of function, minimum value of f. Similarly, your f of xj is the maximum value of f. Okay, now let us see few problems in this. The first problem that we are going to see, okay, let me write down problems. The first problem that we are going to see is find for what values of x the following expression is maximum and minimum respectively. So this is what we have to find for the given function, and the function is 2x cubed minus 21x squared plus 36x minus 20, and find also the maximum and the minimum value. Let us get into the solution process. So let us take the given function. Let f of x be 2x cubed minus 21x squared plus 36x minus 20. Okay, this may be taken as f of x, or if we want, we may take it as y as well, right? Then let us find out the first derivative. So if you find the first derivative of this function, that is 2x cubed minus 21x squared plus 36x minus 20, So this is 2 times of derivative of x cube, and that is going to give you 3x squared minus 21 times of the derivative of x squared, and that gives you 2x plus 36. When you differentiate x, you are going to get 1, and the derivative of a constant is 0. So your first derivative is what? 6x squared minus 42x plus 36. Now we'll have to equate our first derivative to 0. This gives you 6x squared minus 42x plus 36 is 0. When you take 6 as a common thing, x squared minus 7x plus 6 is 0. This tells you that your x squared minus 7x plus 6 has to be 0 because the 6 is not 0. And when you solve this one by factorization, x squared minus 6x minus x plus 6 is 0. And this is when you take x as a common, x minus 6 and minus 1 times of x minus 6 is 0. This very well tells us that x minus 1 multiplied with x minus 6 is 0. So this gives us x is equal to 1 and x is equal to 6. So we have found the first derivative. Now let us find the second derivative of this function. So for which we will have to differentiate our first derivative, and the first derivative is what? 6x squared minus 42x plus 36. So this is 6 times of, when you differentiate x squared, this is 2x, and when you differentiate minus 42x, we are going to get only 42. So which means 12x minus 42. This is our second derivative. Now we'll have to evaluate the second derivative at the points we got, that is x is equal to 1 and x is equal to 6. These two are the points at which we'll have to evaluate the second derivative value. Fine. So this is 12 times of 1 minus 42, which is 12 minus 42, that is minus 30, which is a negative quantity, right? And here this is 12 times of 6 minus 42, which is 72 minus 42, which is 30, which is a positive quantity. Good. So once we got this, make sure that if your value was, the second derivative value is negative when you substitute x is equal to 1. This tells you that your x is equal to 1 is maxima. And when you get your second derivative as positive when you substitute x is equal to 6, that tells you that your x is equal to 6 is minima. Now we have found the maxima and minima. That is, when you give x is equal to 1, your function is going to attain its maximum value, and when you give x is equal to 6, your function is going to attain its minimum value. Now let us find the maximum value of f. So in order to find the maximum value of f, just substitute your maxima in the given function. Your given function is 2 times of 1 cube minus 21 times of 1 squared plus 36 times of 1 minus 20. This is 2 minus 21 plus 36 minus 20, which is 38 minus 41, which is minus 3. Okay, so hope I'm right. And minimum value, now we'll have to find out the minimum value. So for which we'll substitute this one, 2 times of 6 cube minus 21 times of 6 squared plus 36 times of 6 minus 20. And when you do the calculation, this is going to give you minus 128. So this is the minimum value of the given function. Now let us get into the next problem. So the second problem tells you that a firm sells a product at rupees 3 per unit. The total cost of the firm for producing X units is given by C, which is 20 plus 0.6x plus 0.01x squared. How many units should be made to achieve maximum profit? Verify that the condition for a maximum is satisfied. So we'll have to uh, find the value, that is the number of units to be produced in order to achieve a maximum profit. But here we are given only the cost function. We are given with the cost function and we are asked to find out the profit, for which we will do some calculation. Okay, we'll have to think a little and do the things now. If you see, what do we mean by a profit? So this is the revenue minus cost. Am I right? So what is revenue? It is what? Number of units that we sell, or number of units that, okay, number of units that we sell multiplied with the price per unit. So this is 3, and if we decide x is the number of units that we produce, 3x is the revenue, and we know the cost is 20 plus 0.6x plus 0.01 x squared. So the profit function is what? So it is minus 0.01 x squared, 3x minus 0.6x, which means plus 2.4x minus 20. This is a profit function. We'll have to check the maximum value of the profit function. Okay, let us take this as y. So when we take something as, we'll have to write either let we take this way, or we can suffix say. Okay, now let us check the things. What is dy upon dx? This is minus 0.02x plus 2.4. And when you equate this to 0, this tells you that minus 0.02x plus 2.4 is 0. This confirms you that 0.02x is 24. Therefore, your x is 24 upon 0.02. Sorry, 2.4. So this is 240 upon 2, which is 120. So your x value is 120. Now we'll check the second derivative. Your second derivative of this function is simply minus 0.02. Whatever may be your x value, your second derivative value is going to be minus 0.02, which is a negative quantity. This confirms that your x is 120 is maximum. So we have found x is equal to 120 is the maximum, but still we'll have to check what is the maximum value, for which we'll have to substitute this 120 in profit function. So this is what? Minus 0.01 120 whole square plus 2.4 multiplied with 120 and then minus 20. When you do this calculation, you can see that this is 124. So 124, be it rupees or thousands or lakh or crore, this is the maximum profit that we get. Okay, we are given rupees 3, right? So rupees 124 is the maximum profit, right? Now we'll move to the next problem. That problem tells you that A steel plant produces X tons of steel per week at a total cost of rupees x cube upon 3 minus 5x squared plus 99x plus 35. Find the output level at which marginal cost attains its minimum. Okay, let us get into the solution process. Go through the problem once again. You may very well see that a steel plant produces X tons of steel per week at a total cost. So cost function is given. So we are given with what? Cost function, right? So C of x is x cube upon 3 minus 5x squared plus 99x plus 35. This is our cost function. We are asked to find out the output level at which marginal cost attains its minimum, which means we will have to find out marginal cost first, and then we'll have to check the maxima and minima for the marginal cost. So marginal cost is what? If you differentiate the cost function, that is going to be a marginal cost. So when you differentiate x cube, you are going to get 3x squared, and when you differentiate x squared, you are going to get 2x, and when you differentiate x, you are going to get 1, and when you differentiate constant, it is 0. So your marginal cost is x squared minus 10x plus 99, right? So marginal cost, let us take it as y, and then do the checkings. Okay, this is what? 2x minus 10, and when you equate this to 0, you are going to get x is 5, that is 10 upon 2, which is 5, and your second derivative is 2, which is always positive. This tells you that x is equal to 5 is minima. So you have found the minima, the level, output level. When you produce 5 tons, marginal cost attains its minimum. Okay, in this problem we are just asked to find out the output level at which marginal cost attains minimum. So it is enough to find only the minima. Even if you look at the previous problem, we are just asked to find out the number of units that is to be made to achieve maximum profit. That is, when you produce 120 units, you are going to achieve maximum profit. If in addition to this, if we are asked to find out what is the maximum profit, then we can calculate the maximum profit, and that happens to be 124 rupees. Whereas in this problem also, if we are asked to find out what is the minimum marginal cost, that we can do by substituting x is equal to 5 in this equation, right? Which I am not doing here. If it is asked, you may do it. Okay, we'll move to the next problem. So the next problem tells you that the total cost function of a firm is given by C, which is 0.04 q cube minus 0.9 q squared plus 10q plus 10. Here we'll have to find out average cost and marginal cost and value of q at which average variable cost is minimum. So in this problem, we are asked to find out so many things, and all these things are the ones which we have done already. But we will have to pay some extra attention to understand this problem and then have to proceed with. Okay, we are given the total cost. Okay, that's good. So we can find the total cost, and we will have to find out the marginal cost. Okay, first let us do this. We are given that cost is 0.04 q cube minus 0.9 q squared plus 10q plus 10, right? First we need average cost. So in order to find the average cost, so what do? We just divide cost with the number of units. Here q represents the number of units. So if you find c upon q, that is going to give you. So the 0.04 q cube minus 0.9 q squared plus 10q plus 10 upon q. This is 0.04 q squared minus 0.9 q plus 10 plus 10 upon q. So this is our average cost. Okay, so if you want, you can split these things now. That is needed for the upcoming thing, because this is actually this is our variable cost, right? This is variable cost and this is fixed cost. So this quantity will give you the average variable cost, and this is your average fixed cost. So these are required, just that is why I have marked these things. And when you are in the need to find the marginal cost, so that is derivative with respect to q to the function c. Since c is given in terms of q, and when you differentiate this one with respect to q, 0.04 is there as it is, and when you differentiate q cube, you are going to have 3q squared and minus 0.9 multiplied with the derivative of q square is 2q plus the derivative of 10 cube is going to be 10, right? So this is 0.12 q squared minus 1.8 q plus 10. This is our marginal cost. And in the second part of this problem, we are asked to find out the value of q at which average variable cost is minimum. So this tells you that your first of all, we will write our average variable cost. So ABC, what was that? That is 0.4 q square minus 0.9 plus 10. 0.04 q squared minus 0.9 q plus 10. This is our average variable cost. Okay, this one we take it as y. And what is dy upon dx? That's 0.08 q minus 0.9. Okay, when you equate this to 0, you would get 0.08 q is 0.9. Therefore your q would be 0.9 upon 0.08. Fine. When you do these things approximately, you are going to get this is 11.25. When, okay, you don't know whether this is going to give you maximum value or minimum value, for which we'll have to calculate the second derivative. Your second derivative, sorry, with respect to q is 0.08, which is always positive, which means when you substitute q is equal to 11.25, then also you are going to get this value to be positive. Therefore we confirm that 11.25 is minima. When Q is 11.25, average variable cost attains its minimum. And this completes this lecture as well as the calculus for business part 1. That is, we have completed the differentiation ideas, and from the next lecture we are going to get into integration ideas. Thank you.